Hi, everybody. I'm going to talk to you today about why it's important to access NASA PACE imagery via Google Earth Engine. So, for those of you who are familiar, NASA has a platform called Worldview, worldview.earthdata.nasa.gov. And what we can see here from Worldview is this is imagery from yesterday that shows PACE land surface reflectance data along with chlorophyll data that's been extracted from PACE. And this data is from yesterday. Uh, we can see that there's already data that's come in from today over the Eastern Hemisphere. And of course, as the data gets updated, we're going to have data for the Western Hemisphere where we're located. But as we can see, the long and the short is that there's PACE data captured for practically every part of the world on a daily basis. And then this data is extracted into different product formats. And through NASA's Worldview, we can again access, for instance, reflectance data. We can access chlorophyll data over the ocean. So if you wanted to do more than just look at this imagery, you'd likely use a platform like NASA's Earth Data Search, where we can see that there are multiple PACE OCI products. So OCI, or the Ocean Color Instrument, is a sensor on PACE satellite, which stands for the Plankton Aerosol Cloud Ocean Ecosystem Satellite. And again, if we wanted to download that data, we could grab that data directly from NASA Earth Data Search, like we see here, and we could download files directly to our desktop, or we could also grab that data from something called the OBDAC, also from NASA, which is the Ocean Ocean Color and Ocean Biology DAC, and a DAC is a Distributed Archive Center. And if we go to the level 3 and level 4 browser for the OBDAC, we're going to see that you have multiple options for PACE. So the PACE also has a few other sensors that we can see there, but you can see in terms of products, there are a number of products that one can get access to. One of them being surface reflectance, which is reflectance over the land surface. There's also another one called remote sensing reflectance, which is the reflectance over the water. And then from the surface reflectance, they extract what are called land vegetation indices, or land VI. And then from the ocean color data, they extract a number of other parameters, such as the chlorophyll concentration data that we saw in the viewer with from NASA Worldview. So one of the things that you should know about PACE data is, for instance, the surface reflectance data that we can see here. Again, and they have products for daily, 8-day, monthly, and multiple spatial resolutions, like 2-kilometer products that really started getting processed, I believe, in the end of April or early May 2025 timeframe. The 4-kilometer products, which extend to the beginning of the mission, which is March 2025, and a 0.1 degree product, which is something like 11 kilometers. So through this OBDAC, we can grab that data, but the surface reflectance data are essentially really heavy. Particularly if we're dealing with global data. So this global data has 122 bands. And for instance, at 4 kilometers resolution, one of these global mosaics has the volume of 17 gigabytes of data. So therefore, if you wanted to look at data for the whole globe, and not just for one specific time period, but multiple time periods, you'd have to download multiple 17 gigabyte files, not just download that data, import it from the NetCDF format that it's provided in, convert it, say, to a GeoTIFF that you could use in ArcGIS or QGIS, and then that data would be essentially really heavy for your systems. So as a way to help users get access to this data in a different format, I decided through a PACE Early Adopters project that I and another colleague are leading, we decided, you know what, we want to get this data in Earth Engine. And so as a part of that, I have set up a number of GitHub repositories that have different, say, functions or helper functions. And one, for instance, is, let's say you do want to get the data and have it on your desktop. How could you use either the CDAS software or Snap, off of which CDAS is based on, and you want to walk through that and process the data in its original 1.2 spatial kilometer resolution data, so that again you could use it in ArcGIS or QGIS. Again, you can go to my GitHub repository, which I'll post a link to this in the description to this episode. So that's one way of, say, turning the reflectance data from NetCDF, converting it to GeoTIFF that you can then use in your desktop GIS systems. However, if you wanted to do something a little bit more automated, I've also provided scripts for converting specifically vegetation index data or land VI data from PACE OCI, or chlorophyll data, chlorophyll A data over the ocean, and converting that into GeoTIFF format, as well as with the steps for how you'd walk through the OBDAC to then grab that data and then use this R script to process out these vegetation indices and what they stand for. And so again, these scripts are there. In addition to that, however, a little while back, I set up a GitHub repository that I'm calling the PACE OCI Toolkit, which, among other things, this toolkit has functions for discovering data from PACE OCI, as well as other open hyperspectral data sets from NASA, like Hyperion, like EMIT, visualizing that data, visualizing spectral signatures from the data, gap filling the data as necessary, as usually happens with these daily and 8-day data sets. There will be clouds, even monthly data, and so there are functions there for how to fill in missing, the gaps. Also, how to do basic time series analysis of the data, including the surface reflectance or the vegetation index data, and some basic functions for image classification. And if you want, and of course, this is available as a repository for Earth Engine. And if you want to add this repository directly to your Google Earth Engine account, all you have to do is click that bit.ly link that I'm providing there. And the reason why I put it in bit.ly is just to allow for tracking, just to see, which users are using that. On a roughly weekly basis, rather, I'm adding new PACE data, specifically the land VI and the chlorophyll data. I'm importing, ingesting that data that comes out every 8 days. And so I've created this changelog document that you can look and use to see, which data sets have been ingested. And of course, if you want more information on PACE, say through what's called the PACE Land Data Users Group, which is administered by folks like Morgan McKibben over at NASA Goddard, you can find more information on PACE there. In addition to that, I've created a simple viewer that you don't need a Google Earth Engine account to use, and it's based on the Planet Tanager viewer that was developed by Dr. Sam Roy from Spatial Bytes. If you want a video walkthrough of what the toolkit does, I have links here to 3 different webinars that we've giving walkthroughs of the toolkit. And of course, if you're just interested in the background of how we took the data from the DAC, the surface reflectance and the vegetation indices, and then converted that data to GeoTIFF and incorporated it into GEE, here's the workflow for that. This work, of course, is made possible because of support that we're receiving on this side from the NASA Marshall Space Flight Center and the University of Alabama in Huntsville. And as mentioned before, this is being done in the context of an early adopters project for PACE. Also acknowledging, among other people, Dr. Morgan McKibben, who is the PACE mission applications lead, as well as a number of other colleagues of mine from NASA Marshall Space Flight Center and the University of Alabama in Huntsville. With that, I'll just give you a highlight. So for instance, a few weeks ago, we gave a 3-hour-long webinar on the PACE mission. The first part of the webinar was given by Dr. McKibben, giving an overview of what the PACE mission does. The second part is a walkthrough of Google Earth Engine platform done by Dr. Kel Markert from Google. And the last part was an overview of the toolkit provided by myself. In addition to that, just in case you're interested, along with the walkthroughs that have been given of the toolkit, I've also put together resources for those who might be starting with Google Earth Engine, and those resources are provided not only in English but also in Spanish, and they kind of walk you through step by step, particularly for folks who are new to setting up a Google Earth engine cloud project. And before I close it out, I'll also mention that this toolkit that we've put together does have a helper package, which is the larger hyperspectral toolkit. And as a part of that, there's a script, for instance, that documents, the different data sets that we've been ingesting. So some of the data sets at 4 kilometers, we're ingesting it for CONUS, or the continental US. Some of it we're ingesting for Mesoamerica. And then for the whole globe, we're largely, at least for the surface reflectance, we're ingesting it at that 0.1 degrees, which we're then resampling to 10 kilometers. Of course, we're also ingesting the land vegetation index data, all of that every 8 days. And as mentioned before, we recently started also ingesting chlorophyll A data as well. So just to quickly show you the toolkit as it looks like in Earth Engine, as mentioned before, there are functions for data discovery. And so some of these scripts are located over different cities. And if you click on these, they'll essentially tell you what data exists for, not just for PACE, but also for Hyperion, for emit over different cities across the world. And you can customize the locations of those cities to find data for your places, or if you want to display footprints from Hyperion or emit for that data, since the Hyperion and the emit data are not global. And then other scripts for visualizing the data, and I already have one pulled up showing the different global mosaics. And of course, you can click on and off these different data sets. You can use the inspector button to click on the different spectral values. However, we also provide scripts for viewing spectral signatures. And before I walk through the other functions, I'll just call out that there's a script here that says launch PACE OCI viewer. And that will essentially pull up a viewer that, again, you don't need Google Earth Engine to be able to use, but it is based off of Google Earth Engine. And interactively, you can select points, and it'll take those points and display the spectral signatures based on the PACE OCI data for that. And so in this case, I've picked an urban area, Merida in Mexico, a forest area in Belize, for water, an area off of Belize's coast, and for an agricultural area or non-vegetated area, an area with, I think it's agriculture, some part of Mexico, and we can see what the spectral signatures look like. And so this is just a tool that will allow you to do that. And of course, the spectral signatures are based on the different dates of imagery that we have available. And I know we're in August. We'll shortly upload the July surface reflectance imagery for the globe as well. So then just closing this out, in addition to tools for viewing spectral signatures, as mentioned before, there are tools for gap filling using different techniques, tools for doing basic time series analysis, whether it's on the surface reflectance data or on the vegetation index data, as well as doing simple classifications. And since we did a workshop back in July, here are some scripts that were put together by Dr. Africa Flores from NASA Marshall Space Flight Center, showing how you can use PACE and emit data for looking at different things. So with that, I will close this video out. And of course, if you have any questions, please feel free to bounce me an email. Otherwise, I'd highly encourage you to check out the PACE OCI Toolkit in GitHub. Of course, also add the repository to your Earth Engine account. And again, if you have any questions, just let me know. Thank you so much.